Number 10 asks, what is the major product of the following reaction? So this is a little tricky. We have a cyclohexane derivative, and we've got NaOH, so we've got hydroxide. We know that hydroxide is very strong, so we're going to go SN2 or E2, and then we notice that it's very hot. This is going to be an E2 reaction. So once again, very strong base, SN2 or E2. Hot temperature favors elimination. With 2 steps, we've narrowed it down to E2. We know we're going to do E2. First of all, D is wrong, right? We're not doing substitution. We're not doing an SN2 here because of very hot temperature. So that will be not present in significant amounts. A, B, and C, these are our options here. We're trying to do E2. Now, here's the thing. If we're doing elimination on a cyclohexane derivative, we have to look at this in a chair structure to know what's going to happen. I'm going to take the rightmost carbon as being the one with the bromine, and that is pointing up, so I'm going to put that up axial. If we go clockwise 1 carbon in this direction, we've got the methyl pointing down, so that will be right there. If we're going to do elimination, the base has to extract a proton from a carbon that is adjacent to the carbon that bears the leaving group. So we need to be able to get a proton from this carbon or this carbon, and we need to get a proton that is anti-paraplanar to the leaving group. The only way that the resulting pi bond can form, because a pi bond involves lateral overlap of p orbitals, and the only way we're going to do that is if we get a proton that is specifically anti to the leaving group. To do E2 on a cyclohexane derivative, the leaving group has to be axial, and the neighboring proton being extracted also has to be axial. So that is very important, because if we look at the carbons next to the bromine, over here we have 1 proton, over here we have 2 protons, but on this one to the right, the methyl going down is axial. That's occupying the position that we would need a proton to be in order for elimination to occur. Even though we have protons on either side, it is specifically the case that hydroxide can only get this proton. This is the only proton that is available for E2 on this molecule, because it has to be axial and anti to the leaving group. This is going to go there to make the pi bond, and we're going to kick that one off. We do end up with B. This methyl group, no chemistry is occurring at this carbon here. So this remains untouched. We can even draw it in right here. We can show that this proton down, that is the one that got extracted, and we're kicking off that bromine.